Good morning to everyone. I want to make some videos for you under further calculus. We are still on the inverse functions, logarithmic functions, exponential functions. Now, in this video, I shall be solving some exponential equations with you. Now, let's take this example. Solve e to the power 4 minus 5x equal to 9. Now we have e to the power 4 minus 5x should be equal to 9. Now this is an exponential function. So what we need to do is to take the natural logarithm of both sides. So we will take ln of both sides, e to the power 4 minus 5x. Then we will do the same thing here, ln 9. Then with the laws of logarithm, we know that whenever you have an exponent, the exponent can come and multiply the logarithm. So we can write this as 4 minus 5x multiplying the natural logarithm of e should be equal to ln 9. But we know that ln e is equal to 1. So this whole expression is 1. So we have 4 minus 5x should be equal to ln 9. Then we can group like terms as 5x should be equal to 4 minus ln 9. We can divide through by 5, divide here by 5, here by 5. So we have x should be equal to 4 on 5 minus ln 9 on 5. And that is the final answer. That's the final answer. Now let us continue. In this example, we are to also solve 3e to the power 5x minus 1 equal to 2. Now the first thing to do is to divide both sides by 3. So I'll get e to the power 5x minus 1 should be equal to 2 on 3. Now the next thing, take the natural logarithm of both sides. So I'll have ln e to the power 5x minus 1 should be equal to ln then 2 on 3. So I've taken the natural logarithm of both sides. Then I have, using the rules, the 5x minus 1 will come and multiply. We will bring it here. So it's going to be 5x minus 1 multiplying ln e should be equal to, here per the laws of logarithm, if you have ln a over b, it is the same as ln a minus ln b. So we apply the rule here as ln 2 minus ln 3. Now we can divide through. We know that here ln e is equal to 1. So we can see that 5x minus 1, this whole expression is 1, should be equal to ln 2 minus ln 3. Then we can write it as 5x should be equal to ln 2 minus ln 3 plus 1. Then finally we have x to be equal to ln 2 minus ln 3 plus 1 all divided by 5, or we can write it as x is equal to ln 2 over 5 minus ln 3 over 5 then plus 1 over 5, and that is the answer. They are all constants. We can use the calculator to punch, but you can leave your answer here. Alright. Now in this question we are to differentiate. The question says solve the derivative. Solve. It means that this expression means we should differentiate. So what do? We are differentiating d dx of the expression e to the power negative x cubed. So how do we go about this? Now let's start. We will say that let y be equal to e to the power negative x cubed. Now we need to differentiate. To differentiate this expression, the rule says that dy dx is equal to, anytime you have an exponential function and you are differentiating, when you differentiate an exponential function, you will get the same exponential function, e to the power negative x cubed. Then you multiply it by the derivative, that is the derivative of the exponent. When I differentiate the exponent, I will get negative 3x squared. So you multiply by the derivative of the exponent, then you finally multiply by the natural logarithm of the base. The natural logarithm of the base is ln e, but note that ln e is equal to 1. So in this case, this whole expression will be 1. So we have dy dx should be equal to e to the power negative s cubed. Then, let me rearrange it. So we have negative 3 will come first. Negative 3 s squared. Then e to the power negative s cubed. This will be 1. So dy dx is equal to this. Dy dx is equal to this. That's the answer. Now let's solve this. We have to solve the derivative, or we have to differentiate. We have to differentiate s squared e to the power negative 2x. We have to differentiate this. Now take note that this is a product, one function multiplying the other function, so we use the product rule. Now the product rule says that hold the first expression. So we are differentiating. Let y be equal to s squared e to the power negative 2x, and it means that our dy dx will be equal to, so hold the first expression, which is s squared. Then we differentiate this. When we differentiate, we will get the same exponential function, which is e to the power negative 2x. Then it will multiply the derivative of the exponent. The derivative of the exponent, when you differentiate, it will be negative 2. Alright. Plus, we are applying the product rule, so plus. Then you also hold the second one, which is e to the power negative 2x. Then you differentiate the first one. When I differentiate the first one, I'll get 2x. and it will multiply e to the power negative 2x. Now let us simplify. We have dy dx should be equal to negative 2 times s squared will give us negative 2s squared. The negative 2 times negative 2 will give us negative 2 times 2 is negative 4. So we will have negative 4. Then s squared x will give us s cubed. Then we have e to the power negative 2x. We also have e to the power negative 2x. When we apply the laws, no, sorry, there is a mistake. I'm coming. It's not multiplying. Alright, so it's going to be, let's focus on this part. We will have negative 2 s squared e to the power negative 2x. Then here will be plus 2x e to the power negative 2x. Now when we get to this point, we have e to the power negative 2x, we have e, even we have negative 2x, and we have 2x here. So we can do some factorization. Therefore, we can say that dy dx should be equal to, I can factorize 2x, then e to the power negative 2x out. When I do that, here will be left with 1. Then here will be left with negative x. 1x is out, so there will be left with 1x, so x. Then this will be the answer. When you expand, you will get the same thing. So that is the answer. Now let's take this question under limits. Limit. We are to find the limit at infinity. Limit at infinity. Now look, finding limit at infinity, we have e to the power negative x minus 2e to the power 2x, all divided by e to the power negative 2x plus 3e to the power 2x. Now when you look at this expression, you realize that the highest degree is e to the power 2x. The highest degree is e to the power 2x. So we are going to divide all the terms by the highest degree. Divide all the terms by e to the power 2x. That is the highest degree. The highest degree. So let's do that. I'm going to have the limit as x is approaching infinity of e to the power negative x divided by e to the power 2x minus 2e to the power 2x divided by e to the power 2x, all divided by e to the power negative 2x divided by e to the power 2x, then plus 3e to the power 2x divided by e to the power 2x. Now let's simplify that. This implies that we are going to have the limit as s is approaching infinity, negative infinity, to be. Now we are applying the laws of logarithm. When we have e to the power negative 2, now because it is dividing, all the exponents will subtract. So here becomes e to the power negative s minus 2s is negative 3x. Then minus we have 2 as a constant. Then e 2x, they will cancel. So we just have 2. All divided by e to the power negative 2x. Then this is 2x. When they subtract, it will be negative 2x minus 2x, which will be e to the power negative 4x. Then finally we have plus the constant 3 is there. Then we have e to the power 2x all over e to the power 2x again. So that will still cancel. Then we'll be left with 3. Now, when you get to this point, you need to make some analysis. Let's make some analysis. When you have e to the power negative 3x, remember that the limit is approaching negative infinity. So the question you ask yourself is, when you substitute a negative number here, that is a very big number, for example, negative 1000, negative 2000, what is going to happen? It means that as the value is getting bigger, this exponent will be very big. And as the exponent is becoming very big, what happens? Or the other analysis you can do is that this whole expression can be written as 1 over e to the power negative 3x can be written as 1 over e to the power 3x. Then now you substitute the infinity into it. When you substitute infinity, remember that infinity, it is negative infinity as s is approaching negative infinity. So when you substitute a negative infinity into it, what is going to happen is that it's going to be, let's say, e to the power negative 3 infinity. That is what you get. And this expression is still the same as 1 over e to the power 3 multiplying infinity. E to the power 3 to infinity is still infinity. And 1 over infinity is 0. 1 over infinity is 0. Is that right? Now let's try and correct it. Now when we get to this point, let's rather solve it this way. When we get to this point, what we will need to do is that let's again divide through by e to the power negative 3x. So I'm going to have the limit as x is approaching negative infinity of, I'm dividing through by e to the power negative 3x, so it will cancel this, so I'll get 1. Then minus 2 divided by e to the power negative 3x. Then all divided by, I'm still dividing by negative 3x. So when I divide by the laws of indices, I will subtract. So it will be negative 4x minus negative 3x, and that will be negative x. So I'll get e to the power negative x, then plus 3 divided by e to the power negative 3x. So finally I'll get this. Now let's apply the limits. We need to analyze them. Now in applying the limit, you realize that x is approaching negative infinity. So here is a constant 1. Let's put the 1 there. Minus 2 divided by, now if I substitute negative infinity here, it will be negative 3 times negative infinity, and that will still be positive 3 infinity. Positive 3 infinity means a very big number. E exponent, a very big number, will still be a very big number. So this whole expression will become infinity, a very big number. All divided by, again, e exponent negative x. If I substitute negative infinity there, it will be positive infinity. E to the power positive infinity is still positive infinity. That is a very big number. So I'll get infinity here, then plus 3 divided by, the same concept applies here. If I put negative infinity here, I'll get positive 3 infinity, and e to the power positive 3 infinity will still be infinity. So here will be infinity. So finally, I have 1 minus 2 divided by infinity. That is 2 divided by a very big number. Will be, if a lot of people are going to share 2 mangoes, it means that they will get almost 0. So we have 0 here, all divided by infinity plus 3 divided by infinity, again it is 0. So finally I have 1 divided by infinity, and 1 divided by infinity is still 0. So the final answer is 0. Now let's try this question. We are to solve the limit as x approaches 0 from the right of 1 on e to the power ln x. Or let me write it this way. It's supposed to be e exponent 1 on ln x. So this is the expression. All on 2 plus cos pi e exponent negative x. Alright, now in this question, let's focus on the numerator. Let's focus on the numerator. The numerator, we are supposed to find the limit as x is approaching 0 from the right of e to the power 1 on ln x. We are to evaluate this. Now to evaluate this, you need to make some analysis. Now you can pick your calculator and check some few values as x is approaching 0 from the right. From the right means if you have the number line and this is 0, you can have 0.1, 0.001, 0.00001. So you are getting closer to 0 from the right. From the right. So that is what we are looking at. So now we can test with 0.1. If I should put in 0.1 and take ln 0.1, I will get negative 2.30. If I should take the natural logarithm of, let's say, 0.001, I will get negative 6.907. If I get closer to 0, let's say ln 0.00001, I will get negative 13.815. So as I am getting closer and closer to 0, what is happening here? Then you can see that the negative values are also increasing and increasing. So as I keep reducing it and approaching 0, this whole expression will also get to negative infinity. Negative infinity. So we are saying that in this expression, as x is approaching 0 from the right, ln x will become infinity. And if ln x becomes infinity, then 1 over infinity will also be 0. 1 over infinity is 0. Then we will have e exponent 0. Then e exponent 0 is 1. Any number exponent 0 is 1. So the whole expression for the top will be 1. So we are saying that the limit as x is approaching 0 from the right of e to the power 1 on ln x will be 1. Let's now focus on the denominator. Now with the denominator, we are also finding the limits as x is approaching 0 from the right of 2 plus cos pi e to the power negative x. Now here we will have 2 plus cos pi, then here becomes 1 over e to the power x. Now as x is approaching 0, if I should substitute 0 here, e to the power 0 is 1. 1 over 1 is 1. So finally I'll still get 2 plus cos pi. Cos pi. Then what is cos pi? Cos pi means cos 180. Cos 180 is negative 1. So I'll get 2 plus negative 1. Then 2 plus negative 1 is positive 1. Is positive 1. So it means that the whole denominator will also give me positive 1. The numerator give me 1. So finally, if I divide through, I'm going to have, therefore the answer is going to be 1 over 1, which is 1. So the answer is 1. The answer is 1.